Good afternoon, everybody. I'm here to make a video going over angles. So yesterday we went over points, lines, and planes, and I actually didn't have a video for that one because it was just definitions, and there wasn't really anything else to talk about with that. But today with angles is a little bit more that I want to say. But just to review, yesterday we learned what a point, a line, and a plane were, and that these were the undefined terms of geometry, and they can be used to define all other terms in geometry, or almost all. When you're talking about a point, it's literally just the dot labeled point A. When you have a line, there's at least 2 points on that line that you can use to name it, or a lowercase letter. So you could either call this line D, or you could call it line AB, or BA, the line symbol on top. Similarly, for a plane, this one is drawn using a parallelogram with at least 3 points on the inside and an uppercase curly letter that you can use to name it. And you can name it using any 3 points in any order. Then we talked about two terms, line segment and ray, which are pieces of lines. A line segment is a finite piece that's just between the two endpoints, and this is something you could measure. And it has the same naming as a line. For a ray, this is a piece of a line that extends infinitely from one single endpoint and just keeps on going. And you name it endpoint first, and then the second point on the ray with the ray symbol on top. Collinear means together on a line, and so when points are collinear, all of them can have a line draw through them. On the other hand, if they're non-collinear, there's no way I can make a straight line go through both A, B, and C at the same time. I sure could try, but I'll never get all three on at the same time. Similarly with coplanar and non-coplanar, you can have all your points in a plane together or not. So they're either together in the plane or not. And lastly, two lines intersect at a point and two planes intersect at a line. So then today we have angles. Now angles are formed by two rays, which are called the sides of the angle, with a common endpoint, the vertex of the angle. So I drew an example of an angle over here, with the vertex being B and the two rays coming off of it having the points A and C on them. I also labeled a 1 inside because that's another way that they could label an angle. And lastly, I wrote its measure of 45 degrees outside because we'll be using that later in the notes. First, let's talk about how to name this guy. So naming might seem a little bit silly in a math class, but it's actually so important in geometry to have an accurate name because the name is representing the actual thing, and you want it to be a close match. Otherwise, you might accidentally end up describing something else. It's kind of like if you're trying to talk about a cat and the cat is black, but you say it's orange. No one would be able to tell you're talking about a black cat if you call it orange. The same way in geometry, if you use the name incorrectly, no one will be able to know what you're talking about. So when we name a letter, when we name an angle, almost all the time, you will use 3 letters to name it. And the vertex has to be the middle letter every single time. That's part of sort of the identity of an angle, is to be able to look at the name and know exactly what the vertex is by seeing the middle letter. So for our angle up here, we could name it AB in the middle, C, or CBA. Both of those would work perfectly because B, the vertex, is in the middle of the name. The symbol in front is just representing an angle. One letter can be used if no other angle shares that vertex. So I could name that angle up there angle B because there are no other angles with a vertex at B. There's literally only the one. And that would look like this, angle B. This gets a little bit more tricky when you have more than one angle at B. So I have a little drawing here to demonstrate that. So here's our angle ABC, but I added another ray coming from B. So we actually have two angles that are sharing vertex B. So if I said angle B, we would be confused as to whether we're talking about this one with the one blue arc or this one with the two pink arcs, because both of them have a vertex at B. In this case, we would have to use the three letters to name them, as angle ABC is markedly different from angle CBD. All right. The last way that you may see an angle named is by a number, but this only works if the angle is numbered. So in the case above, I numbered it with a number 1, so I could show you angle 1 is another way you may see an angle represented. And the last note is that when you're referring to the measure of an angle, meaning the number associated with the degrees, you have to use a lowercase m in front, because when you're talking about the measure of an angle, that's different from the physical angle itself. So the measure of angle ABC is 45 degrees. Or you could say the measure of angle B or the measure of angle 1. It works in front of any name for an angle. All right. Now let's introduce you to some terms about classifying angles. So for the most part, all angles are going to fall into one of these four categories: acute, obtuse, right, or straight. An acute angle is a small little bitty angle that's less than 90 degrees. An obtuse angle is a big boy greater than 90 degrees. A right angle is that perfect square corner of exactly 90 degrees. And a straight angle is flat across exactly 180 degrees. So lastly, I wanted to do some examples where we looked at naming and labeling angles. So here we have this angle JKL, and we have an obtuse angle here. And it wants us to name the vertex, name the sides, and 3 ways to name the angle. Now the answers are already put up here, but I'll talk about them. So with point K being the vertex, all we had to do was put K in, as K is the point that is shared by both this ray and this ray. In order to name the sides, we had to name the rays, starting with our shared point K, going to L for our first name, so ray KL with the ray symbol on top, and then for the other one, ray KJ with the ray symbol on top. And then because this angle is just a single angle all by itself, we can name it 3 different ways. 1, using just the vertex, angle K, and then 2, using 3 letters, either angle JKL or angle LKJ. In the second example, we have a lot more going on. So we have a lot of different rays coming out of this shared point A. And that makes up a total of 5 different angles. So first it wants us to name the vertex of angle 2. Now there's a lot to look at here, so we just want to isolate angle 2 here. That would be DAE. Well, I see that both the rays of D and E on it are heading towards point A, so that's our shared point, meaning it's a vertex, A. Naming the rays works the exact same as naming them above. So for 4, we go to angle 4, and I see that we have AB and AF. Next, it wants us to name angle 5. So here, we have 2 different ways we could do it. We aren't going to use the one letter because if I say angle A, I could be talking about angle 1, 2, 3, 4, or 5. So instead, I want to use the 3 letters, CAB or BAC. Same for angle 1, CAD. All right, so I went pretty fast through that, but just know that you could pause the video at any time to take a moment to take everything in. I just didn't want to make a super long video. All right, bye.